So one of the most important things that you need to be able to do and that you need to be able to do quickly is to be able to convert between radians and degrees. And so there's two ways of doing this. There's a slow way and there's a fast way. So I'll show you the slow way first just to make sure you understand. One thing you want to notice is if you agree 180 degrees is the same thing as pi radians. So if I took these two things and made a fraction out of them, this whole fraction is worth 1 because they're the same thing on top and bottom, and whenever you have the same thing on top and bottom, it's equal to 1. Just like if I put 5 over 5, that equals 1. Well, these are the same thing, so they equal 1. And so what I can do is I can use this, remember that we call this a conversion factor. What I can do is I can use one of these equations, either this one or this one, and I can take it times my numbers so that it cancels out the degrees and gives me radians. So I'm going to want to use the pi radians over 180 degrees because then the degrees cancel out. And so I'm left at 120 pi over 180, and then I need to reduce that. 6 goes into 12 2 times, and 6 goes into 18 3 times. So 120 is the same thing as 2 pi over 3. We can do that also with changing radians into degrees. So if you look at the bottom here, these are actually radians, so I'm going to want to change that into degrees. So I have 180 degrees over pi radians because then my radians will cancel out. And if you notice, the pi's will cancel out. So now I have 5 times 180 degrees over 4, and then I'm looking at changing this. 4 goes into 180, let's see, 25, and then another 20, so 45 times. And 5 times 45, carry the 225 degrees. Now there's a lot of calculating there, and that's actually somewhat difficult. So then another way of doing it is knowing your unit circle. Now your unit circle is, let's see if I can figure out how to explain this here. Is built, actually we've already gone over the unit circle. So if you look at 1/3, now what I'm not talking about, what I'm really talking about when I say 1/3 is I'm talking about pi over 3. Okay, so if I had pi over 3, but instead of writing pi I'm just talking about 1/3. So when I'm thinking of 1/3, I'm thinking of 180 divided by 3, a third of 180. So a third of pi, basically. Remember 180 and pi are the same thing. And I'm looking at 60 degrees. And then I want to look at the multiples of 60 degrees. So I've got 60, 120, 180, 240. So I just keep on adding 60 degrees till I get to 360. So this is 300, and this one's 360. So these are really good numbers to know. All of these numbers are multiples of 60. I can also focus in on the 6, the 12, the 18, the 24, the 30, the 36, those are all multiples of 6, and then you're just adding a 0 to it. So knowing these is really important. So if we go to the 1/4, pi, well, let's skip 1/4 for right now. 1/6 would be pi over 6, so I'm looking at 180 divided by 6, that's 30. So I've got 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Now that's a lot. And I want you to notice that we have some repeats. We have 60 in both of these. And we have 120 in both of these, and we have 180 in both of these, and we have 240 in both of these, and 300 in both of these, and 360 in both of these. And so if you notice, even though I have 60, 120, 180, 240, 300, 360 in the pi over 6 ones, if I ever see those, I'm actually going to go to the pi over 3 ones and do that, and we'll practice that. So then let's look at the 1/2. That'll be an easy one to look at. 1/2, I'm looking at pi over 2. So let's see, the pi is over 2, that's 180 divided by 2. That gives me 90, 180, 270, and 360. So as I look at those, anytime I see any of those are on the axes, and so I'm going to be thinking about pi over 2 and multiples of pi over 2, and I'll explain what I mean in a second. And then I have the 1/4. Now that 1/4, so think about it, it's pi over 4. So 180 divided by 4, which is 45. So I've got things like 45 degrees, 90 degrees, 135, 180, 225, 270, 315, and 360. And once again, I've got some repeats here that I'm going to want to look at. So 90 and 90, 180 and 180, 270, 270, 360, 360. So if that happens, you're not going to want to go with the small number, the pi over 4. You're going to want to go with pi over 2. So how does this coincide? Let's go to another page and check that out. If I'm trying to take a degree, let's say, and I want to change it into a radian. So let's just pick some degree. So let's just say 240 degrees. And I want to change that into a radian. I'm first looking at, what is that a multiple of? See, I have a multiple of 30, 60, 45. Those are basically the ones. And then, well, and then 90, I guess. But if I look at that, 240, 30 goes in there 8 times, and 60 goes in there 4 times. Now remember, if 60 goes into it, I want to go with that. So 60, though, 180 divided by what number gives me 60? 180 divided by 3 gives me 60. Remember, 180 is pi. So I'm really looking at 60 as being pi over 3. So if I think 60 goes into 240, I'm going to use pi over 3. And we decided 60 goes in there 4 times, so this is going to be 4 pi over 3. And that's what it is as radians. You're also going to want to be able to go the other way, where you take something that's in radians already. So let's say that I have, I don't know, 2 pi over 3, and I want to turn that into degrees. This is actually easier, because pi over 3, that's going to be 60, and I want to take that times 2 because of the 2 there, and so I get 120 degrees. Okay, so let's say I had another one. Let's say I had 5 pi over 6. So I want to turn that into degrees. Well, pi over 6 is 30 degrees times the 5 there. That gives me 150 degrees. So that one is actually pretty easy. Now you'll notice I actually skipped over doing the pi's over 4, and there's a reason for that. I don't know my multiples of 45. So we're looking at these angles here. I'm looking at that one, which is 45 degrees. I'm looking at this one, which is, hold on a second, 135 degrees. This one, which is 225 degrees, and this one, which is 315 degrees. So in degrees, I want you to notice a couple things. As I work my way down, I have 45, 135, 225, and 315. So in my 10 spot, it goes 4, 3, 2, 1. And then my 100 spots move up. It's 0 here, then it's 1, 2, and 3. So what I do a lot of times is I'll draw the picture and just kind of relate that. Okay, it starts at 45 and works my way down, 35, 25, 15, and then my hundreds work its way up. And then as far as the radian version of that, this is going to be pi over 4, and then this would be 2 pi over 4, which reduces. This one would be 3 pi over 4, and then 5 pi over 4, and 7 pi over 4. Okay, so if I'm working on a pi over 4 one, or one that ends in the 5s, I know that it's going to be a pi over 4 one, and so what I do is a lot of times I'll just sketch this out real quick so that I can relate them pretty quickly. So we're going to practice this in the class. Don't worry too much about it, but if you ever need to go back to this video, it's here for you.